Day 16 of 90, and today we kill a problem that bites every Rust learner. You wrote 3 almost identical sort functions, one for string, one for i32, one for your custom struct, and they all do the exact same thing. That's not dry, that's copy-paste with extra steps. By the end of these 5 minutes you'll write one generic function that handles all 3, and the compiler will enforce every rule for you. Trait bounds and where clauses are the grammar of Rust generics. Let's learn the grammar. Here's the naive fix. You reach for generics, fn largest t, list, t. Looks clean, right? You loop through, compare items with if item largest, and the compiler slams the door. Error, binary operation cannot be applied to type t. Why? Because t could be anything: a file handle, a network socket, a struct with no notion of greater than. Rust refuses to guess. It will not let you call a method on a type unless you've promised that type actually has that method. That promise is a trait bound. So we make the promise. Fn largest t, partialord, list, t. That t, partialord, is an inline trait bound. It reads as, t can be any type, as long as it implements partialord, the trait that gives you and. Now item largest compiles, because the compiler knows every t has comparison. One bound, inline, perfectly readable. This is the sweet spot for inline syntax, a single constraint right there in the angle brackets where your I already is. But real functions need more. Say you want to print each item as you go and clone it out. Now you need 3 traits: fn largest t, partialord plus display plus clone, list, t. Read that signature out loud. The angle brackets are bloated, the constraints crowd out the actual parameters, and your function name is buried. Add a second generic type with its own bounds and it becomes genuine line noise. This is the wall. The fix isn't fewer bounds, it's moving them. Enter the where clause. Watch the same function recover its readability. Fn largest t, list, t where t, partialord plus display plus clone. The signature up top is clean: a generic name, parameters, return type, exactly what a caller scans first. Then where spells out the contract underneath, like documentation the compiler actually enforces. The rule is simple: 1 bound, keep it inline; 2 or more, move to a where clause. Where clauses aren't syntax sugar, they're the readable contract between your function and everyone who calls it. Now let's build something real: a generic table renderer for a CLI tool. Fn print underscore table t, rows, t, where t, display plus debug plus partialord. Display gives us clean user-facing output, debug gives us the colon fallback for diagnostics, and partialord lets us sort the rows before printing. One function. It now accepts a slice of strings, a slice of i32s, or a slice of your custom record struct, as long as that struct derives those 3 traits. Those 3 brittle copy-paste functions from the intro? Deleted. Replaced by this single signature, and the compiler guarantees any type you pass actually supports formatting and comparison. That's the whole promise of bounds: write once, the compiler enforces correctness at compile time, 0 runtime surprises. And here's the trap to avoid: don't overconstrain. Every bound you add is a demand on your callers. If print underscore table never actually clones a row, do not slap clone on it, you'd reject perfectly valid types for no reason. Bound exactly what your function body uses, nothing more. The compiler error messages are your guide here. It tells you precisely which trait is missing on which line, so add bounds reactively, not defensively. One preview before we wrap, because where clauses go deeper than this. You can bound associated types: fn sum underscore li, iter, I, u32 or I, iterator item equals u32. That says accept any iterator, as long as it yields u32s. You're no longer just constraining the type, you're constraining what's inside it. That's the next level of expressiveness, and it's how the standard library's most powerful generic functions are built. Try writing one tonight against a VQ32 and a custom iterator. Day 16 done. The takeaway: 1 trait bound goes inline, 2 or more move to a where clause, and you bound exactly what your code uses, no more, no less. That single rule turns line noise signatures into self-documenting contracts the compiler enforces for free. Tomorrow we go deeper into generics. Subscribe for day 17.